เราฟอร์มสินสอดที่อาคารจังหวัดน่าน Today we will introduce cleaning silver jewelry from everyday items using the principle of electrochemistry. Many people, especially in Nan province, love wearing silver jewelry, but a common issue is black tarnish from silver reacting with sulfur. So we are looking for a way to remove black tarnish without stopping while keeping its shines and original weight. Objectives of the experiment. First, to study and identify a method for cleaning tarnished silver with minimal weight loss using the principle of electrochemistry. Second, to remove most everyday items, inexpensive materials, or discarded objects to effectively clean silver and add value to these items. Silver rings were chosen for their uniform size, affordability, and suitability for small-scale experiments. The tarnish is also easy to observe.
In the first experiment, we create black tarnishes of silver sulfide on silver rings by putting those rings in a container with cooked boiled eggs for 12 hours, and we'll be using them in our second experiment. We observed how black tarnishes on the silver rings react with acidic solution. Acidic solutions can barely break them down, as they cause the silver rings to lose their weight, because they require some polishing afterward. Hence, we looked for better ways to clean silver without causing any weight loss. We discovered that using a mix of 3 coffee spoons of sodium hydrogen carbonate, 6 milliliters of water, and 1 coffee spoon of salt effectively cleans the tarnishes while protecting the ring's weight. Placing this mixture in a bottle with a silver ring wrapped by 5 x 5 cm aluminum foil and seal it. Then, let it sit at room temperature for either 15 or 30 minutes and heated it for 5 minutes. After cleaning, we wiped the ring dry and weighted it using RGB measurement app to check how shiny it was. Our results showed that the silver rings cleaned in a heated solution worked the best and removed tarnishes quickly, bringing back its shine. In our third experiment, we compared the ability to remove black tarnishes on silver rings when using aluminum metal in different sources. We tried aluminum foil used to wrap food, blister aluminum foil, aluminum bottle caps, aluminum cans, and baking foil. Each type was wrapped around its own ring. We also separated them into 2 groups. One group stayed at room temperature for 30 minutes while the other was heated for 5 minutes. After cleaning and other steps as previously experimented, we found that the rings was wrapped in aluminum foil used to wrap food, and those wrapped in blister aluminum foil were equally good at removing tarnishes. But the blister aluminum foil worked a little better, so it led us to the fourth experiment. We compared the ability to remove black tarnishes on silver rings of aluminum foil used to wrap food and blister aluminum foil. We decided to cut both into small pieces to make them more comparable. After wrapping these smaller pieces around a ring and putting them in the cleaning solution with heated for 5 minutes, we were pleased to see that they worked just as well in removing tarnishes without any weight loss and restored the ring's shine.
The chemical reaction that occurs between aluminum and silver sulfide can be explained as follows. First, aluminum foil used to wrap food and blister aluminum foil contain aluminum metal which act as a reducing agent. Oxidation, half reaction. Second, silver sulfide in the form of silver ion oxidized back to metallic silver. Reduction half reaction and redox reaction. The aluminum metal has standard electrode potential of a half cell value at minus 1.60 volt, which is lower than the silver which has standard electrode potential of a half cell value at 0.8 volt. This makes aluminum more capable of losing electrons than silver. Sodium hydrogen carbonate functions to regulate the pH of the solution, creating a slightly basic environment. Sodium chloride is increasing the solution's electrical conductivity that enhances electron transfer between aluminum and silver ion. Using hot water speeds up the redox reaction.
Conclusion of the experiment. First, the solution makes by mixing 6 ml of water, sodium hydrogen carbonate 3 coffee spoons, sodium chloride 1 coffee spoon, and small pieces of aluminum foil used to wrap food, or blister aluminum foil 1 glass. When heated or using hot water, effectively remove black tarnish and accelerate the chemical reaction. The weight of the silver ring remain the same and its light reflection is similar to the original silver ring. Second, sodium hydrogen carbonate, sodium chloride, and small pieces of aluminum foil used to wrap food or blister aluminum foil are common household items that have no significant value but can be utilized to clean silver jewelry effectively.
The science project involved designing a small-scale chemical experiment between the dream of clean chemistry, exploring method to clean silver jewelry with black tarnish by using chemicals commonly found in daily life. These chemicals are non-toxic, applying the principle of electrochemistry.
Thank you for your attention.